Good morning to you all. My name is Karthik. I am from CSMA. My roll number is 234G1A3362. Today my topic is examples of CPU in digital logic and computer organization. Examples of CPU. Agenda. Introduction to CPU, components of CPU, basic functions of CPU, types of CPU architecture, multi-core processors, role of cache memory, CPU registers, CU and ALU, CPU and performance factors, modern CPUs, and conclusion. Introduction to CPU. Definition. The central processing unit CPU is the brain of the computer that performs instructions from software, handles calculations, and makes decisions. Role. The CPU processes data, controls hardware, and enables the execution of programs and tasks. Importance. It is essential for any computing devices to function, acting as the core component for all processing activities. Components of CPU. ALU, Arithmetic Logic Unit. This performs arithmetic and logic operations. Example, addition, subtraction, comparisons. Control Unit, CU. Direct the flow of data and instructions within the CPU, coordinating its operations. Registers, small fast storage locations that holds data and instructions during processing. Basic functions of CPU. Fetch. The CPU retrieves fetches an instruction from memory or RAM. Decode. The control unit decodes the instruction to understand what action needs to be performed. Execute. The arithmetic logic unit or other parts of the central processing unit carry out the instruction. Example, performing a calculation or moving data. Types of CPU architecture. RISC, reduced instruction set computing, uses a small simple set of instructions, focuses on efficiency and speed. Examples are ARM processors, CISK, complex instruction set computing, uses a larger set of more complex instructions, allows more work per instruction, but may be slower in execution. Example, Intel x86 processors. Multi-core processors, central processing units with example multiple processing units cores on a single chip, enabling parallel processing. Benefits: improved performance. Multi-cores allow simultaneous execution of tasks, improving multitasking and performance in multi-threaded applications. Energy efficiency. Multi-core processors can perform more work per clock time or cycle, often using less power than a single core processor at equivalent performance levels. Examples: modern central processing units like Intel Core i7 or i9 or AMD Ryzen Future 468 or even more cores. Role of cache memory. A small high-speed storage located inside or near the CPU that stores frequently uses data for quickly access. Types of cache. L1 cache, faster and smallest, located close to the CPU core. L2 cache, larger and slightly slower than L1, usually shared between cores. L3 cache, largest and slower and shared by all cores on the CPU. How cache improves performance? Reduce the time the CPU needs to access the data from slower RAM, enhancing overall processing speed. CPU registers, small fast storage locations within the CPU used to hold data and instruction during processing. Types of registers: general purpose registers store immediately data for calculations. Special purpose registers perform specific functions such as the program counter and the status register SR. Role in the CPU: registers hold value that the CPU needs quickly during the execution of instructions, making them essential for fast computation. Control unit, CU. The control unit is responsible for directing the operations of the CPU, coordinating the activities of the ALU registers and other components, functions, fetch instructions, retrieves instructions from memory, decode instructions, interprets the instruction to determine the required actions, control data flow, sends slow control signals to other components, ensuring the proper execution of instructions. Importance: acts as manager of the CPU, making sure all the parts works together efficiently and in sync. Arithmetic and logic unit. The arithmetic logic unit is the part of the CPU responsible for performing arithmetic operations like addition and subtraction and logical operations such as comparisons. Functions: arithmetic operations, basic math operation like addition, subtraction and multiplication, division. Logical operations: comparisons, example greater than, less than, equal to, and bitwise operations like and or not. Importance: the ALU handles all calculations and logical decisions, making it essential for processing data and executing instructions. CPU performance factors. Clock speed determines how many instructions the CPU can perform per second. Higher clock speeds generally mean faster processing. Core unit. More cores allow the CPU to handle multiple tasks simultaneously, improving the multitasking and performance in parallel applications. Cache size. The larger cache reduces the need to access slower RAM, speeding up the retrieval and overall processing. Instruction set. The set of instructions the CPU can execute impacts compatibility and performance with certain software. Thermal management. Efficient cooling allows the CPU to maintain higher performance without overheating. Modern CPUs, example Intel Core i5, i9 or i7 and AMD Ryzen 5 i7 9 with advanced features. Key features: multi-threading, enhancing efficiently by handling multiple threads. Turbo Boost increases clock speed for demanding tasks. Integrating graphics, improving multimedia performance. Trends: AI optimization, energy efficiency, and smaller technology loads. Example 5nm. Conclusion: the CPU, often referred as the brain of the computer, plays a vital role in executing instruction and enabling the functionality of software. Through the presentation, we explored the key components of the CPU, including the ALU control unit registers, the cache memory, each contributing the CPU's efficiency and processing power. Performance factors like clock speed, core count, and cache size have a significant impact on the how quickly and effectively a CPU can handle tasks. As the technology advances, we expect CPUs to contribute improving in multitasking, processing energy efficiently, and specialized capabilities, including integration with AI. The CPU will remain an essential driver of computer performance and innovation in the future. Thank you.